Okay, hi guys. As I mentioned in my post, this video will be about the discussion of time dilation and length contraction problem solving. But before that, I believe you're here because, yeah, you read that post. And in that post, I would just like to emphasize what I mentioned, which is you answering activity 5 and 6. Activity 4 and 5, which are both time dilation, which are both problem solving. Okay, so you'll be answering these two, and you can submit that until April 16. Now, this video, you can watch it anytime you want, up until April 16, okay, before you submit your activity 4 and 5. So, I believe you know already the reason why we are doing this. It's because of the time constraint, several class suspensions that we have for April 8 to 12. Okay, so yeah, we really need to congest some topics and some to be delivered in this mode. Okay, so yeah, I will no longer be discussing this inside the classroom. So once we resume, we will be proceeding already with um the waves. Okay, waves and optics. So that's where we will resume. Okay, so let's have now the time dilation. All right, so when we say time dilation, it is the stretching of time an object experiences as it approaches the speed of light. Okay, so in simple words, it only means that as we go faster in time, the faster you move. I'm sorry, what's that? Okay, the faster you move, the slower the time. Okay, sa Tagalog, 'pag mas mabilis yung takbo mo, ang mangyayari daw is mas babagal yung oras mo. So that's why we say here it's stretching. Kasi 'di ba kapagka iko-compare mo yung isang bagay, actually this is how we can we can actually describe that. So let's say you have a situation wherein you have a person on earth observing a person on outer space or an astronaut outer space, and this astronaut will be traveling from earth to planet X with a velocity that is close to the speed of light. Let's say 80% the speed of light. Okay, this person is traveling 80% the speed of light. So yeah, what will be the application of time dilation in this case? How do we apply time dilation in this scenario? So the astronaut in the spaceship traveling 0.80 c or 80% the speed of light would actually have a slower or shorter time recorded compared to this person on earth. And what are we recording? Both of them, we asked both of them to record how long it would take this spaceship to travel from Earth to planet X. Okay, I repeat. We will be asking the person on Earth, just at rest, observing this spaceship, how long it would take this spaceship to travel from Earth to planet X. And that is also the same question that we will be asking this astronaut who is on board on this spaceship moving, right, from Earth to planet X. So we will be having two different recorded time. One from the Earth observer and the other one from the astronaut. So if we're going to consider the speed of this spaceship, it is 80% the speed of light. It is close to the speed of light, meaning it is very fast compared to the ones that we are experiencing on a daily basis, right? So this is where time dilation would be observed, okay? So if we're going to get the data from these two observer, one from Earth, one from the spaceship, the astronaut on the spaceship will be giving us a shorter period of time recorded compared to the one on Earth observing that spaceship. Kasi nga sabi natin 'di ba? Pag mas mabilis yung takbo mo habang nagre-record ka ng oras, mas maikli yung mare-record mo. Actually, kung i-compare mo yan dun sa ibang observer na nasa labas nung gumagalaw ng moving vehicle na yon. So that is what we mean when we say stretching. Okay? So yeah, so this several slides here will be giving us an idea how we are able to derive this equation here of time dilation. So you can read those several slides for you to have a knowledge of how we got or derived this equation. But given the time constraint, I will no longer be focusing on that. Okay, but if you have some question, you are very free to ask me, of course. All right, so we have this equation here, and there are four quantities to be considered. So we have two time measured in here, which will always be the time recorded in the moving reference frame and the time recorded outside of that moving reference frame just at rest. If we're going to use the previous scenario that we have, as an example, the astronaut on the spaceship and the observer on Earth, the time that will be recorded by the astronaut will be this proper time, the T sub zero. Okay? Because the T sub zero is the time recorded in the moving frame. Okay? So, di ba sabi natin when we say inertial reference frame, we say that the acceleration is zero. In all situations that we will be having here in time dilation and length contraction, these are all assumed to be inertial. Okay, meaning if it is moving, it has a velocity that is constant for it to have a zero acceleration. And if it is not moving, well, it means that it is at rest. Okay? So those two situations are considered inertial because both of them have a zero acceleration. Okay? So all the time when we are referring to reference frames here in our situations for time dilation and length contraction, it would be either of those two. All right? So yeah, so the T sub zero will be the time recorded by the person on uh or the clock on the spaceship or in a moving reference frame, not limited to spaceship. Okay, what about this T in here? This T is what we call the relative time. Okay, relative time will be the time recorded by an observer outside of the moving reference frame. Okay, kung nag-observe ka lang sa labas, tinitingnan mo yung gumagalaw na object na yon near the speed of light, then yung i-record mo na oras, that is what we'll call relative time. Nakukuha po ba? I hope, no? So, dalawa lang naman yung scenario dyan palagi, guys, eh. For time dilation, there would always be something that is moving near the speed of light. Okay? And kung magre-record ng oras na nandun mismo nakasakay sa moving reference frame na yon, then proper time ang tawag doon. Kapag ka naman, okay, so what about the other two quantities in here? So we have the V, which is the velocity of the moving frame. Magano ba kabilis yung gumagalaw ng moving frame na yon? In our example earlier, di ba, we have a spaceship that is moving with a velocity 80% the speed of light, the 0.80 c. So yun, yun yung velocity na i-record mo dito. Then this c is the speed of light, which is equal to 3 times 10 raised to 8 meters per second square. But we will no longer be substituting that kasi we will be canceling it out as we do the simplification. So you don't have to substitute it, you just write it as it is, letter C. Mhm. Okay, so this is summarized. The one that I have mentioned earlier is summarized in this slide. So you could just take a look at this. This is exactly what I have mentioned earlier. Okay. Yeah. So moving forward. Okay, so what we have here will just give us an idea of what is the implication of time dilation. So Di ba we have that essential question earlier or in the start of this discussion wherein we ask ourselves, we try to reflect if it is possible for us to travel in the future. Technically, this time dilation would answer to us yes. Okay, it is a resounding yes. Because if you're going to, di ba, analyze it, kapag ka sumakay ka sa isang spaceship or any vehicle that is very close to the speed of light, you would be, um, kumaga, mas kaunting oras yung mako-consume mo and you will be able to travel already in, um, kumbaga, more years than those observing on Earth. 'Di ba? Kasi kung iko-consider mo, nag-o-observe lang siya sa Earth, longer yung time niya, pero paglabas mo, mas konti lang yung na-consume mong oras sa'yo, pero it's actually, let's say, for example, 30 years already on Earth. But the one that you have experienced on your spaceship traveling near the speed of light is less than 30 years. So it's kind of a traveling in the future in a sense. That's how we define tra- a possible traveling in the future using the ideas of time dilation. Okay? Yeah, but you have to remember, guys, that time travels only one way. It is forward. So, sad to say, we cannot go back in time. Kumaga, you cannot really change whatever mistakes you had in the past, no? Di mo na po pwede talagang baguhin yung mga nagawa mo na from before. So, that's according to time dilation, no? Because we say that time only moves forward. Well, you have this technical possibility of going to the future if we have kasi there's this if you already have that vehicle who can which can travel near the speed of light kasi as of the moment guys it's not yet possible since you would be using a tremendous amount of energy for you to create such vehicle. Okay, and also physically for human it's well kind of impossible also for us to be in a vehicle that moves near the speed of light. So there would be some physical effect on us. All right, so let's see if you're able to really understand the concepts of time dilation. So we have this scenario that in the future, a young astronaut may rush up to an old gray-haired man and calls out, "How are you doing, my son? How might this be possible?" All right, so I would like you to pause this video and try to reflect. Let's see what your answer will be. Okay, so I hope you paused the video and tried to reflect and answer, no? So, in this case, guys, this is really possible if we're going to apply the one that we have just explained. Diba? Kasi if that young astronaut traveled in a high-speed spaceship, it means that he only consumed less time compared to the person observing on Earth, which is his son, yung anak niya. Di ba parang, kung titingnan mo, uh, I mean, if we're going to compare it to the ones that we're experiencing now, parang imposible naman talaga, di ba, na yung anak niya ay mas matanda pa sa kanya. Paano naging posible yon biologically? But if we're going to apply the time dilation concepts, it is possible. Okay? Basta yung magulang magta-travel lang siya sa isang vehicle near the speed of light. Okay? Kasi ibig sabihin nun, hindi siya mabilis tumanda compare doon sa anak niya na nasa Earth na tumatandang mas mabilis kaysa sa kanya. Okay? That's actually the very plot of Interstellar movie, if you've seen that. Okay, what about this one? Hanapin ko na yung sagot. So sabi dito, does time dilation mean that time actually passes more slowly in moving reference frames or that it only seems to pass more slowly? Actually, the correct answer is yes. It really passes more slowly. Everything slows down relative to a non-moving reference frame, but you will not notice it. Okay? So, talagang babagal yung oras mo in comparison to those observing in non-moving reference frame. Okay, so yung mga at rest lang na nag-o-observe sa'yo, yung oras nila would be longer than what you have. Pero actually, it would still be the same seconds kung paano tumatakbo yung seconds. So, like, for example, pag magbibilang ka, 1, 2, 3, 4, 5, the regular interval wherein you would be able to get 1 minute for 60 seconds, gano'n din naman yung nandun sa may ano mo spaceship mo Pero nga lang, kung i-compare mo siya doon sa nasa Earth or doon sa at rest na observer, mas mabagal yung sa'yo compared sa kanya. Okay, medyo parang magulo siya, no, in a sense. Pero if we're going to really look at how we have derived this equation, yung kaninang sinasabi kong three previous slides, yan, that's where you will be able to discover how we got that difference. Okay, pero we're just only after the main idea for now, given the time constraint. Okay, so tatandaan ninyo ha, everything would slow down in that moving reference frame if we're going to compare it with a moving reference frame. Uh, if we're going to compare it with a reference frame that is at rest. Sana nakuha po yon. Um, pero kung ikaw yung nakasakay dun sa loob ng spaceship, hindi mo mapapansin yon. Bumabagal yung tibok ng puso mo compare doon sa nasa Earth, pero ikaw sa sarili mo, hindi mo mapapansin na bumabagal pala yung tibok ng puso mo. Or yung oras dun sa may spaceship bumabagal. Or ikaw mas bumabagal kang tumanda. Hindi mo mapapansin lahat yon. Okay, but it is actually slowing down. Kung makikita mo yung pagbagal niya kung magko-compare ka. Okay? Pero kung titingnan mo lang siya, just inside the spaceship, you would not notice it. Okay? Yeah. So let's proceed already to our sample problems in here. So lagay ko na rin yung sagot. Sabi dito, a satellite travels at 0.95 C for 4.0 years ship time. How much time would pass on the Earth? Okay, so let's try to enumerate first the given, right? So sabi dito, we have these two values, the 0.95 C, which is the speed of the moving vehicle. So lalagay mo dyan, V is equal to 0.95 C. And this 4.0 years ship time, oras yan 'di ba? 4.0 years, oras yan. So, kaninong oras ba yan? That is the time recorded, ship time kasi. So, ibig sabihin sa loob ng spaceship. Okay? Sa loob nung ship na, kumaga considered natin yung satellite na yon, 'di ba? As the moving reference frame. So, yung recorded na oras doon sa satellite na yan is 4.0 years. Kumbaga, nag-travel daw siya according doon sa recorded time ng satellite is 4.0 years. Sino bang gumagalaw? Yung satellite or yung nag-o-observe dun sa Earth? 'Di ba? It is the satellite. So, yung record na oras ng satellite is what you will be considering as the T sub 0. So, 4.0 years. Okay, the one that we are being asked here is the time it would take to pass on Earth if recorded by the observer on Earth. Okay, so T is what we are looking for. So let's write the equation. T is equal to T sub 0 over square root of 1 minus B squared over C squared. So very simple. We don't have to do any derivation, right? So you just have to substitute the values 4.0 years over square root of 1 minus um, 0.95 C square over C square. Remember, we will no longer be substituting the value of the C, right? The 3 times 10 raised to 8 meters per second square. Because if you're going to notice here, it will just be cancelled out. Diba? So kapag ka um, square ka, ganito gagawin guys ha. You have to take note, the 0.95 C, both of them are inside the parentheses and they need to be square. Okay, so each of them needs to be squared. All right, so if we're going to distribute this square here without solving anything else, so 4.0 years over the square root of 1 minus the 0.95 square. Kasi mag-distribute ka, di ba? Square mo muna si 0.95. Then after yan, square mo rin si C. So 0.95 square is equal to 0.9025. Okay, then we will be squaring the C as well. So magiging C square siya. Diba? So meron kang 0.9025 which came from the square of the 0.95 and then the C would be also squared. So ito yung magiging sagot mo. Then you would be writing the C square as it is. And as you can see, we can cancel this 2C squared. Alright? And that would lead us to t is equal to 4.0 years over square root of 1 minus 0.9025. Okay. Both of them inside the square root. So if you're going to do your math, you use your calculator, you will be able to get this answer here. Alright? So how do we check if our answer is correct? So this is one way for you to do it. All the time that we have a vehicle in a certain problem, moving very fast compared to the speed of light or near the speed of light, the time recorded by the moving reference frame should always be less than the one recorded by the reference frame at rest. Okay? Laging ganito ha. 'Di ba sabi ko nga kanina, stretching of time, yung ibig sabihin ng time dilation. And the faster you go, the slower your time. Sino ba yung nagta-travel dito na mabilis? Yung satellite. Ano ba yung recorded na oras ng satellite? 4.0 years. Ano naman yung recorded na time nung observer on Earth? 13 years. So, do we have a correct concept here? Consistent ba siya? Yes. Right? Because the 4.0 years recorded by the satellite is less than the time recorded by the observer on Earth. Alright, so what about this one? Let's have another sample problem. So sabi dito, a spaceship is traveling at 0.85 C. It has been gone from the Earth for a total of 12 years as measured by the people of the Earth. How much time passes on a spaceship during its travel? Okay, so this time we will be looking for the time recorded by the people on this spaceship. Yung mga nakasakay dun sa spaceship, pag sila yung tanong mo, kano na ba sila katagal na wala? Okay? Or nag-travel in the outer space. Kasi ang recorded na oras ng mga tao dun sa Earth, uh, who are at rest on Earth is 12 years. So, ano ba yung ating given? So, ang given natin is the time recorded by the frame at rest, diba? Yung Earth, people on Earth, 12 years. Okay. And then, we also have the velocity of this spaceship. Gaano kabilis tumatakbo yung spaceship? 0.85 c. So what are we going to look for in this case? We are looking for the t sub 0, the time it takes for this spaceship according to the people on board to travel. Okay? So, kumbaga, pag tinanong natin yung mga nandun sa spaceship, ano kaya isasagot nila since sila yung nag-record habang nandun sila sa loob? Okay, so we will be using the same equation. T is equal to T sub 0 over square root of 1 minus V square over C square. So since we are looking for this term here, we just simply need to in order for this to be derived, we just simply need to actually you have two ways to do it. You can multiply both sides with this denominator, or you can just simply multiply both sides. So either way, it would give you the same answer. Okay, but since I already put this parenthesis in here, I'll just do the multiplication both sides of this whole term. Okay, so that would cancel out this one on this side. It will give us this equation now. So t sub 0 is equal to t times 1 minus v square over c square. Alright? So you are now ready to substitute. So t sub 0 is equal to t. T is 12 years. Then square root of 1 minus what is v? 0.85 c square over c square. Okay? So if we're going to square 0.85 and then this c square here, makakancel po ito. It would give us 12 years 1 minus 0.7225. 0.7225. Okay, and then the answer of that would be 6.3 years. Okay, diba layo, no? So, kung titingnan mo, we have this less than 6 years difference between the time recorded by the people on Earth and those people on the spaceship. So, well, we have to double check again. So, T sub 0, is it less than T? Obviously, it is. Okay, so yung na-record na oras na nandun sa may spaceship is 6.3 years. Pero yung na-record na oras na nandun sa Earth is 12 years. Kumaga, dito sa Earth, let's say for example, 2024, di ba? After 12 years, it would be 2036 already. So sa atin, 2036 na, 12 years na yung nakalipas. Pero sila, dun sa spaceship nila, for them, and biologically also, it only, it only took them 6.3 years. Kumaga, 6.3 years pa lang yung nakakalipas sa kanila. So pag bumalik sila dito, ang year na maaabutan nila is 2036, pero yung na-consume pa lang ng katawan nila is 6.3 years pa lang. Nakukuha nyo? So, ganun yung ibig sabihin ng time dilation. Okay, so sample problem number 3. So, a spaceship has been gone from the Earth for a total of 7 years ship time. The people on the Earth have measured the time for the ship to be away for about 26 years. How fast was the ship? Express the answer in terms of C. Okay, so we are given two recorded times here, right? So it is different from the previous two examples because this time we are looking for the speed of the spaceship. Okay, the V. So the recorded time on Earth, which is our T, is 7 years. And then since gumagalaw yung spaceship, in this case, the recorded time there, ayun, wait lang. A spaceship has been gone from the Earth for a total of 7 years. The people on the Earth have measured the time for the spaceship to be away. Baliktad ako, di ba? Napastop ako kagad kasi naisip ko, i-record ko yung T sub 0, 26 years, which is mas malaki sa T sub 0. So, dun pa lang, di ba? Makikita mo na kaagad na kapag ka ganun yung nagawa mo, may mali. Kasi dapat hindi siya mas malaki. Okay, so our T is 26 years. And the time recorded by the observer on the spaceship is 7 years. According to them, it only took them 7 years to travel, but when we asked the people on Earth, they told us it is 26 years. Okay, so yeah, let's find how fast this spaceship is moving for them to say that they only traveled 7 years. So, starting from our general equation, T is equal to T sub 0 over square root of 1 minus V square over C square. So this one, you can just take note of how it was derived, because there would be cases wherein you would be asked to solve the velocity of the moving frame as well. Okay, pero if, yeah, you just take note of the derivation in here. So, what do we do first? So, iangat muna natin tong buong denominator natin, no? We will be doing that by, sige, mag-ano na lang ako, cross-multiply para katamad magsulat eh. Ayan, cross-multiply natin. Kasi ganun din naman yun eh, di ba guys? This t here is automatically with 1 on its denominator. Okay, so that would give us now t sub 0 is equal to t square root of 1 minus v square over c square. Okay, then what do we do next? Because we would like v to be the one remaining on one side. So gusto nating tanggalin lahat except the v. So we can do that by dividing both sides first with t. It would lead us to t sub 0 over t equal to 1 minus v squared over c squared. Then what do we do with this square root? We can square. Okay, we should square both sides to cancel out this square root. So, makakancel na yan. You'll have t sub 0 square. Kasi distributed yan, di ba, sa kanilang dalawa. T sub 0 square over t square is equal to 1 minus v square over c square. Then, we would like this negative sign to be eliminated. So, lipat natin yung buong term na to sa kabila. Then, buong term na to sa kabila. Pagpalitin lang natin sila. So, v square over c square is equal to 1. Magiging negative naman ito kasi positive siya, di ba? Kasi lilipat mo sa kabila. So, negative t sub 0 square over t square. Okay, we only have the c square and we only have the c square and the square of the v remaining. Okay, so what do we do now? Okay, what we can do first is to multiply muna both sides with c square para ma-cancel si c square. No, matira na lang yung v square. So, by doing that, we will have v's, la, ano nangyari? Na-erase. Okay, nawala siya. Yan, okay. Nire-write ko na lang kasi na-erase nitong aking pen. Ay, delikado pala. Kailangan di kasi ano yun, yan. Okay. Sige, so this is where we left off, 'di ba? For me. Okay. So, yan. So, ang gagawin natin ngayon, guys, since we only have the v square left here, why did we have that c square already on the other side? It's because we multiplied both sides with c square in order to cancel out that c square on the denominator of the v square. Okay? That's why we got that c square already on the other side. So, the only thing remaining here that we would like to cancel out for v to be the only remaining quantity on one side is the square. Okay, so to do that, we will be squaring both sides. Getting the square root, I mean. So square root of v square, it will be cancelled out. Then you have this whole term here. Actually, you can already cancel out the square for c, but not for the t sub 0 square and t square. Okay? Kasi they are together in one fraction eh. Okay, so you'll be having here now the final equation for v. You can take note of this. This is our final equation for v whenever you would like to find for the value of v or the velocity of a moving reference frame. So 1 minus t sub 0 square over t square c. Okay, the substitute na lang tayo. 1 minus t sub 0 is 7 years squared over t square is 26 years, and then we will be squaring that. Then you have the c on the outside. That's why we have this kumbaga request here on the last part telling us to express it in terms of c. Kasi baka there would be a tendency wherein some of you would be substituting the value of c. Okay, but you don't have to do that. You just have to express it as it is. Okay, so if we're going to do the math, the square root of 1 minus 7 square root of 1 minus 7 years is square over 26 years is square. It would give us an answer of 0.96 c. So, sobrang bilis niya, no? Almost close to the speed of light talaga. That's why you have that big difference in terms of the time recorded by the observer on Earth and the observer or the person on the spaceship. Diba? So, parang somehow you really traveled in the future kasi ang difference, so almost 20 years. What more if you are traveling 0.99, okay, or 99% the speed of light? So, mas malaki, di ba? Alright, so at this point, I will be asking you to try this on your own. You have the choice if you would like to try this much better. I hope you really do. If you got this answer, very good for you. Okay? So, yeah, once you're done with that, you can already proceed to this activity number 4, time dilation. So, these are 4 questions related to the ones that we have just discussed. So, you will be answering this in Canvas. I mean, you'll be submitting this on Canvas and you'll be writing it on any decent paper as long as you will be submitting it in PDF file. Okay, so let's move forward with length contraction. So length contraction, guys, this time it is defined as the shortening of length of an object as it approaches the speed of light. Sige, parang I would like to make this two-part na lang para hindi masyadong mahaba, no? So I'll just maybe cut this one at this point. You just watch the second part for the length contraction.